This video goes over some applications of rational expressions. So the first thing that we're going to do is determine the area of the triangle in simplified form. So I already know that the area of a triangle is 1/2 base times height. And I have two expressions. I have an expression for the base of the triangle, and I have an expression for the height. What I want to do is I'm going to make that substitution. So I've got 1/2 base times the height. So 5x minus 35 over x plus 2. I notice that I'm multiplying and I want to be able to cancel out. So that means I need to do some factoring. So I can, so let's put that in there to remind them. So 4x squared over, let's see, that's going to factor to x minus 7, x minus 9. And then my second one, I can common factor the numerator. So 5 times x minus 7 over x plus 2. That doesn't factor. So I can only cancel one thing, but that makes things a little bit simpler. And now I can multiply across. So I have 20x squared all over 2 times x minus 9 and x plus 2. And then I see one more thing I can simplify. I can divide by 2, which is going to leave me with a final expression of 10x squared over x minus 9 times x plus 2. The last thing that I need to do is state my restrictions. So from the end, I've got minus 2, positive 9. And from the beginning, if you remember, I canceled out one of my factors as 7. Putting those in order, I've got minus 2, 7, and 9 as my restrictions and as my simplified expression for the area. In my next example, I'm going to determine the area of the trapezoid, and the formula is given for you here. So let's identify those ones. So I've got L1 is the length of the bottom, L2 is going to be the length of the top, and then L3 is going to be the height here. Not L3, the height. So let's take a minute and make all those substitutions. So I've got x cubed minus 4x over x minus 3. And I'm going to multiply by L1 plus L2 all over 2. So first thing that I need to do is some simplification. So I'm going to do some factoring at the same time. So I've got x times x squared minus 4 all over x minus 3. I notice that I can actually factor a little bit further. I'll do that in my next step. I'm also going to notice that I now have to add two rational expressions together. So 4x plus 2 times x minus 2 all over x times x minus 2. And now I notice that I am dividing by 2. And I've just rewritten that to make it a little bit easier. Okay. On the side, I'll do this. So if I have 1 over x plus 2 over y over 3, this is the same as 1 over x plus 2 over y divided by 3, just bringing that denominator up. And now I'm going to continue factoring my first one. So x minus 2, x plus 2, all over x minus 3. And then my second one here, I now have, it looks like 6x minus 4 all over x times x minus 2. I'm going to invert so that I have all multiplication here. And now I'm going to go ahead and do some canceling and do some simplifying here. So what do I notice? I'm multiplying all the way across. And I'm just going to write it out one more time here because I see one more thing that I can actually factor. So x minus 3, and then I'm going to take out a 2 here as my common factor. So that's going to leave me with 3x minus 2 over x times x minus 2, and then times 1/2. So now I'm going to see what I can cancel out. I see that I have an x. I can cancel those. I see that I have an x minus 2, and I see that I have the number 2. So in my numerator, I'm left with x plus 2 and 3x minus 2. And on my denominator, I'm left with x minus 3. Finally, stating my restrictions, x can't equal 0. That's the factor that I canceled out here. 2, I also canceled that out here. And then 3, my remaining factor in the denominator. Let's do one more example. Here, I'm asking you to determine the length of a rectangle given the following information. And we're going to state the restrictions as well. So here, I know that an area of the rectangle is going to be length times width. And I know that I'm looking for the length. So that means that I'm going to take my area divided by the width. So let's go ahead and plug that in here. I've got x over x minus 3 divided by x squared minus 2x over 3 minus x. The next thing that I'm going to do is invert and multiply. And I'm going to do some factoring at the same time. So here I've got 3 minus x. I'm going to pull that up to the top. And I'm going to factor out a negative at the same time. The x squared minus 2x, I'm going to factor out an x and pull that to the bottom. So it's finishes inverting my fraction. The next thing that I'm going to do is I'm going to do my canceling. So I notice I've got an x and an x minus 3 and x minus 3. And so what I'm left with is minus 1 over x minus 2. The last thing that I need to do is state my restrictions. So from what I started with, I have, oops, I don't need an L there. Let's use an x. My restrictions on x are that it can equal 2, can equal 3 because I canceled that out here, and that it can't equal 0 because I also canceled that out right here. So that's going to leave me with my final expression for the length and my restrictions. So those are examples of applications involving rational expressions. Being able to generalize an expression for lengths or areas or widths allows you to test many different values for x and many different values for the side lengths to see what the optimal result is.